Hey guys, BuildZoid here, and today we're going to be taking a look at another DDR5-8000 setup with the Ryzen 7 9700X again, but this time on the ASUS Crosshair X870E Hero motherboard, which was provided by ASUS, so big thank you to them for the board. The memory kit is the same one I used last time, so the V-Color Manta X Prism 2x24GB 8000 CL38 XMP kit, which was provided by V-Color, so big thank you to them for the memory. And that is, of course, based on Hynix 24GB MDI memory chips, and it's a single rank configuration. And yeah, so for me, this is the first time I'm having DDR5-8000 work on a 4DIMM motherboard, which is pretty neat. Also, you can see I do have a fan on the memory sticks, which this time is definitely necessary because for this setup I decided to push the timings a bit more, because now that I know, like in the previous video, I verified that this 9700X definitely is capable of doing DDR5-8000, so now that I know that DDR5-8000 is definite, like the CPU doesn't have a problem with this, I can start pushing things around a bit. So, yeah, so the fan this time is a necessity. Let's get the specs out of the way and take a look at the stress tests and stuff. Actually, I'll make this all like full size. So as you can see, it's just been running Karhu for like the last day and a half because I kept putting off like recording this video for like 12 hours. Or 12 hours? Something. Well, the thing is, like, I went to sleep when Karhu was at, like, 10-ish hours, and then it was at, like, 18, and I was like, well, it's at 18, so I'll wait for it to get to 24 hours, and then, yeah. Anyway, so it ran for a day and a half at this point. So I guess, well, actually, I won't stop it just yet. We'll just check the memory temperatures right now. And yeah, the memory sticks are at like 47 degrees. Now, admittedly, that's the hub temperature, so that's not like the temperature of the actual memory chips, just due to where the temperature sensor is positioned. But that is a perfectly reasonable temperature for DDR5 memory sticks. Though I will point out that because we are on a single CCD CPU and a Ryzen CPU, those memory temperatures are quite a bit lower than what you would get if you were on an Intel chip running similar settings, because on Intel CPUs you don't have a massive memory bottleneck in the form of the Infinity Fabric. So, and that bottleneck is even worse on the single CCD chips, which basically means like single CCD chips run the memory a bit cooler than the dual CCD chips. And then Intel CPUs run the memory really hot because they can actually use all the, well, there isn't like a massive bandwidth bottleneck inside the CPU itself. But anyway, so yeah, the memory sticks are maxing out at like 47, 40, yeah, like 48 degrees, which is a perfectly acceptable temperature for them. So, I mean, I wouldn't take my chances with not having the fan, because I am running, 65,000 refresh interval. But yeah, like this really isn't a, like this doesn't really run that hot, so it's not like the fan has to be going super fast or anything. Actually, speaking of the fan, how fast is it going? I guess we won't find out, because I can't see an RPM reading. Well, doesn't really matter. So yeah, so Karhu, no errors in just an absolutely insane runtime. I think this is probably the longest Karhu run I've ever done. I think. Yeah, probably. So no errors in that. Also ran like just under 3 hours of Y-Cruncher and 16 hours of Prime 95 for similar reasons to why Karhu ran for a day and a half. Yeah. Also, I do apologize for the state of the Prime 95 test. I was like messing around with getting the like readout to be less of a mess, and I made it worse. So we only have the stop confirmation for one of the tests. Unless we like scroll through, and yeah, like that's just not practical, is it? Actually, I'm not even sure. Wait, no, we do have all the other tests in there as well. So yeah, like I tried to do something to make it like not a horrible mess, but the Prime 95 UI is just it's just not good. So yeah, but I didn't see any of the workers crash. Like when I stopped the test, because this is stopped manually, like all the workers were still running, and then I started messing around with the window viewing options to try get everything to like fit nicely on the screen, and here we are. So yeah, I am absolutely thrilled with Prime 95's UI. Um, anyway, so yeah, it passes all stress tests. Like this is extremely stable. Um, and in terms of the settings, this time I'm actually running, you know, uh, like better timings than the last time I showed the DDR5-8000 with this CPU. So the main thing is more voltage, mostly just to get the cast latency down. It doesn't really help anything else because this is like that's just the typical Hynix memory chip behavior, right? Like you raise memory VDD, and the only timing that gets any lower is cast latency. So I mean, sometimes you'll also be able to lower like TRRDS and TRRDL, but this is 24 gigabit MDI, so even that doesn't really react. So, yeah. Anyway, we are at 8000 CL34. Also, that VDD voltage isn't minimized. And the reason it's not minimized is, like I showed you earlier, the memory isn't really running very hot. So I really don't see any reason to like try minimize the memory like VDD voltage because it's like the temperatures are fine, so it doesn't matter as far as I'm concerned. Um, anyway, so yeah, it's kind of that in terms of what I want to show in the OS. Oh right, also no errors in hardware info. So yeah, DDR5 8000 CL34, very very stable. So anyway, let's go into the BIOS and take a look at what kind of settings I'm running for this. Wait, I don't think I took a screenshot of this, so just in case. There we go. And now we can restart. So, I guess while we're waiting for this to reboot, I did try messing with some ADI kits on this board. That did not go well, like, at all. Other than that, yeah, so, and I'm not sure if it's like, it might be the ADI kits that I'm using, because they're not kits that are actually on the QVL for the motherboard. So, I don't know. I am going to be getting some, like, proper Expo ADI memory kits, hopefully this month, and we'll see if that makes a difference, but the ADI kits that I've tried so far, like, this board just doesn't play well with them. So, yeah. Whereas I haven't tried other MDI kits yet because I wanted to try this one because this one I'm certain, you know, can do 8000. This is like, yeah, I've done DDR5 8000 with this kit many, many times. So I don't have to worry about like, oh, it might not work this time. Like if the motherboard and CPU are capable, this kit will work. Unless there's some specific incompatibility with this kit, but I've not run into that yet. So I haven't tried other MDI kits, but I do plan to do that later. Yeah. So the main thing is like I'm not sure if the ADI if the ADI support should be better than what I've experienced with the board so far. But yeah, that's going to be something I'm going to be testing some more. But so far for 8000, I think the 24 gig DIMMs are like. I'd say the 24 gig DIMMs with ASUS, you're probably going to have the most success. With MSI, and I need to test this some more, but MSI seem to have better support for ADI. At least the ADI kits that I have. Anyway, the BIOS version that I'm on is 0505. I did try 0606, but I wasn't really having a lot of success with it, so I swapped over back to 0505. But I also swapped CPUs, so it might And then I also swapped CPUs after switching back to 0505. And yeah, so like still need to do more testing on that. And this is just like one thing that's super annoying with memory testing is like there's so many things to test and it takes so long that like yeah. And the thing is if you're on a bad BIOS, right, and it's causing errors that are like 3 hours into stress test, then it just like it takes so long to prove that it's a BIOS issue that just it is incredibly annoying. So I ended up going back to 0505 because yeah, I'm not sure. Like the 0606 BIOS was doing things to the to the resistances that I thought were really weird. Which might just be because they changed how the memory controller is like configured on the 0606 BIOS, but I mean not the memory controller, the PHY, but you know, I can't see into that, so I was just like, well, this is weird and nothing is very stable, so I'm going back to 0505. Anyway, so yeah, so I do have the OCP turned on. Don't think that's really necessary, but depending on the BIOS and the motherboard, it can, like, having an XMP profile or an Expo profile turned on can change a few settings. I think the main thing it does on ASUS is it enables the reduced memory training time on this board, I think. But anyway, yeah, so I have the OCP turned on, but ultimately all of the timings are set manually, at least all the relevant ones. Now, FCLK is at 2000, and we are in 2 to, like for DDR5-8000, we're obviously in 2 to 1 mode. So I have the FCLK at 2000 because that synchronizes with the memory controller, and that gives us a nice latency reduction. So basically, from a gaming perspective, if you're pushing 2 to 1 mode, you always want to synchronize the Infinity Fabric, unless you're at like 7200 or something. But if you're at 7200, you should really just use 1 to 1 mode instead, as far as I'm concerned. Yeah, for like DDR5-8000, for like gaming performance, you want 2000 FCLK. For heavy like memory bandwidth workloads, like Y Cruncher, you'd actually want max FCLK of like say, well, as high as your CPU can go, basically. This chip, I don't actually think this one does 2200. I haven't really tested that yet very much. Yeah, so this is just set basically for minimum latency right now. Then SoC voltage, 1.1 volts, because in 2 to 1 mode, you don't really need a lot of SoC voltage. And this isn't minimized. This could probably go lower. I just didn't want to, you know, make my life more complicated than it already is at DDR5-8000. Now, voltages. Manually set VDDIO to 1.45. I did try a few other voltages, like lower voltages, that made things way worse. So at least for me, with this kit and this CPU, the whole like ASUS motherboards like high signaling voltages thing seems to be holding true on this BIOS version. I don't know, maybe the newer BIOS prefers lower voltages, especially because that one has just like completely different resistance settings. Yeah, at least on 0505 with this memory kit, 1.45 volts VDDIO, 1.4 volt, 1.42 VDDQ, 1.05 VDDP. I didn't actually try to like optimize the VDDP voltage at all. Though, like, well, the thing is, I haven't tested I haven't optimized, like, I haven't tried optimizing it specifically with this CPU. Because I did mess around with VDDP when testing other chips on this board, and I found that generally 1.05 was just kind of the best voltage, at least for 2 to 1 mode. In 1 to 1 mode, you can use much less VDDP. Yeah, for this setup, 1.05 is, well, like, this is the only value I tested, and it works, and I don't see a reason to change it, so I'll just, you know, so I'm happy with that one. And this is, like, at this point for the ASUS boards, VDDP at 1.05 is, like, my go-to voltage. Like, that's just what that's what I start with, and then if it doesn't work, then I might look into, like, if I'm having stability issues, then I'll look into changing VDDP. Usually that makes things worse, so, So, yeah, 1.05 it is. I already mentioned 1.42 VDDQ. Basically, ASUS boards just like high VDDQ and high VDDIO, relatively speaking. Like, I consider anything north of 1.4 to be quite high. And less than 1.4 I would consider to be kind of low. Well, no, not really. If it was less than 1.3, I would say that is like actually low. But yeah, 1.42 I'd say is on the higher side of things for VDDQ. And then VDD 1.62 because I am pushing for CL34. Though I didn't check if this is like the minimum voltage that this would work at. This is probably running a bit more voltage than it really needs. Because, yeah, I just set 1.62 and it worked and I was like, cool, I'm not dealing with this. Because like I showed when we were like when it's running Karhu, the memory is maxing out at like 48 degrees. It's fine. Like this is not going to harm the memory sticks. The memory isn't running super hot, so I'm not going to go and do anything about it. I mean, I do have a fan on the memory sticks, but I'd say like if you're going to be pushing DDR5, you should have a fan. Like you just should. And honestly, even with DDR4, if you were gonna push it, like some of the memory chips, some of the DDR4 memory chips are significantly more temperature sensitive than DDR5 is. So, because on DDR4 there are some memory chips where even like your primary timings significantly depend on operating temperature. And so there having a fan is arguably more beneficial than it is on DDR5. Anyway, let's take a look at the timing. So CL34, TRCD48, TRP44. The TRP might go a little bit lower, but it won't go as low as what you would see with a lot of like 16 gigabit ADI kits. Yeah, 24 gigabit just doesn't do TRP as low as ADI does. 16 gigabit ADI does. TRAS52. This isn't fully minimized, but it's not too far off minimal values because 24 gigabit MDI has a pretty high TRC limit. And so, yeah, there's not really much room left for improvement in TRAS and TRC. TWR is completely minimized. That can't go any lower. Refresh interval at 65,000. TRFC at 666 because that's easier to type in than 640. And actually, I think even like 620 might work sometimes on some kits, but the performance difference between like 620, 630, 650, 666, they all kind of perform the same. And this one takes pressing the one button 3 times, whereas the other ones require you to press multiple different buttons, and I'm really lazy. Anyway, next up we have TRFC2 and TRFC same bank. Neither of these is neither of these is in use on the AM5 memory controller, so we can just ignore them because they don't do anything. RTP at 16. This could potentially go lower, like it might work at 12 instead of 16. It's also not going to really change performance very much, but yeah, like sometimes it doesn't work when you set it to 12, and that's why I prefer, like, for 1-to-1 mode, I would generally set it to 12. For 2-to-1 mode, because we're at much higher speeds, I usually set it to 16, because I'd prefer not having to deal with RTP not being stable sometimes. TRRDL at 12, and this is just a downside of 24 gigabit MDI, is that it doesn't do TRRDL as tight as 16 gigabit ADI. On ADI, you can typically, even at 8000, you can usually run like 8832. 24 gigabit MDI doesn't do TRRDL8 at DDR5-8000. So 12832 it is. Then TRRDS at 8, because setting it any lower in 2-to-1 mode, as far as I know, doesn't even work. In 1-to-1 mode, you can technically set TRRDS to like 4. In 2-to-1 mode, as far as I know, everything just, like, anything less than 8 just becomes an 8 anyway. So, yeah, no reason to set it any lower than that. Also, with 24 gigabit MDI, that wouldn't even be stable, if I remember correctly. So, yeah, TFAW 32, because if TRDS is 8, then 8 times 4 is 32, so TFAW 32. WTRL 16, WTRS 4. This is about as low as both of these go at DDR5-8000. Then read to read SCL8, read to read SC1. One wacky thing about this board, actually, I'm not sure if it's specific to this board, but the SC timings will actually default to 2 on the XMP profile, which is not great for performance. That's kind of an understatement. It's terrible for performance. So, yeah, if you're tuning 2-to-1 mode, make sure that your SC timings are 1. Because if they're 2, that's really bad. Because this is your back-to-back. Man, I wish AMD used the Intel naming convention for the tertiary timings. Because, yeah, like SCL, SC, well, SD and DD, that's fine. But SCL and SC, not fine. So on Intel, this would be same group, and this would be this would be different group. And alternatively, you could go long and short for naming them. But anyway, this should always be 1. If you want good performance, this should always be set to 1. And yeah, the board will default it to 2. And I think Expo kits don't do that. I think that might be specifically for an issue with like XMP memory kits. Though I don't have any 8000 rated Expo kits, so I don't know. Maybe they do, which would not be great. Then right to right, same group, 8. This could probably go lower, but there's not really any reason to set it lower. Because it's right operations, and we're on a single CCD Ryzen CPU, so it's not like Ryzen has a pretty doesn't seem like Ryzen already doesn't seem to have a great write bandwidth to the memory to begin with on like the dual CCD chips. On the single CCD chips, it's way worse. So yeah, we're not gonna be bottlenecked by like back-to-back write operations on the memory end of things, so we don't really need to worry about minimizing that. Write to write SC set to 1 again. And then write to read I have set to 6, and read to write to 20. I think this could go lower, but I ran into some issues when, well, that was admittedly messing with a different CPU on this board, but I ran into some issues with when I had this set at 4. I don't think it was actually this timing's fault. I think the CPU was just not great, or at least not as good as this one. But yeah, for like not spending more time, fixing things, I ended up running that at 6 instead of 4. I think at 4 it would probably work. And TRDWR I think might work at 18 instead of 20, but it's also not really going to perform any different. And then luckily I didn't have to change anything else on this BIOS version. I mean, it would probably well, auto is obviously setting into UCLK equals MCLK/2. But yeah, so that's like that. So a pretty simple setup. Though I will say, well, like I mentioned, I was messing with a different CPU on this board before I went with the 9700X, and based on that, I would say that this board, like if you want to have DDR5-8000 working or even higher speeds working, you're gonna need a better CPU, like a chip that potentially does 8000 on some other boards is not necessarily going to do 8000. Like, if it's barely doing 8000 on some other boards, then it probably won't do 8000 on this one. So, yeah. Then again, the main issue I have with, like, testing with the 9700X is that it just... Like I mentioned earlier, like even though we're at like 8000 CL34 1.6 volts, the memory is maxing out like 48 degrees Celsius. And that's basically because this CPU has a massive memory bandwidth bottleneck. And so I have concerns about like memory testing with this chip where it's like, what if it just doesn't load the memory hard enough? And at this point, I'm seriously considering picking up like a 9900X just for memory, like just to try get something with a better 2-to-1 mode memory controller and also 2 CCDs. Because yeah, it's kind of annoying the situation I'm in where I have like, well, I have a second 9950X, and that does do 8000 on the ITX board, but it doesn't do 8000 on this thing. Which is why I'm like, oh, you need like, and then I have the other, like I have my first 9950X, which is really good in 1-to-1 mode and doesn't do 8000 at all. Then there's the second 9950X, which is worse in 1-to-1 mode, but is barely function, like just about does 8000 if paired with the right motherboard. And then there's this 9700X, which does 9000 with very few issues, though I haven't run this chip through a bunch of different boards. However, again, I do kind of wonder if this thing being so easy to run at 8000 isn't directly related to it being a single CCD CPU. However, if you have a 9800X3D, that's also going to be true, right? Like if you have a 9800X3D, that's a single CCD CPU. It's going to have the same memory bandwidth bottleneck that this has. So if you're tuning your memory with a 9800X3D, the 9700X is actually a perfectly good like comparison point, right? Like if a 9700X runs well, then a 9800X3D will run equally well on a given board. At least assuming that the memory controllers are roughly the same silicon quality, right? Because obviously if you lose the silicon lottery with one of the two CPUs, then it's just going to suck. 1 CCD or 2 CCD isn't relevant when the I/O die is garbage. Oh, and one thing I forgot to mention, I did raise the power limits on the chip because especially when running Prime 95 large FFTs, it would run like on the stock power limit, which is 60, like, well, it's not 65 watts, it's like 88 watts, but yeah, on the stock power limit, the CPU was running at like 4.4 gigahertz, which I didn't really think was an adequate operating frequency for memory stress testing. So I just raised the power limits to fix that. Anyway, so honestly, I am like, this is the first time I've got an 8000 to work on a 4-DIMM motherboard. At the same time, this is also by far the best memory controller I have for 9000 series right now. And the funny thing is, like, 7000 series and 9000 series do actually have some differences in how the motherboard BIOS interacts with them. So even though technically the I/O die is physically very similar, it's not exactly the same. The 9000 series has some like bug fixes applied to it. And also in terms of how they behave on various motherboards, it's very different. So I do kind of want to go and test, like, the other issue I see is that this is the first 4-DIMM motherboard that I've tested with this 9700X extensively, right? So it's the first one that does 8000 probably because this is the CPU to do it with. And so now, like, and then, like, the next thing I want to do is check if, like, other boards with this CPU also work at 8000, because in the past, that's been like a massive struggle for me, is getting DDR5-8000 to work on anything with more than 2 DIMM slots. And even the 2 DIMM motherboards, like the ITXs and the Tachyon, have a, like, it's been hard getting 8000 working on those. So, yeah. Lots more testing to do, but still, like, I'm pretty impressed with how this worked. But yeah, I do still need to do more testing and like more comparisons. So yeah, I don't really like, so I guess that's it for the video. Because yeah, I don't really have anything more to say. Like, And I guess that's like the annoying thing, isn't it? Is like when you have a memory controller that just works at 8,000, it just works at 8,000. Imagine that. You don't have to bend over backwards fixing stability issues if it just works out of the box. Yeah, it basically just works out of the box. And then you tighten up the timings to make the performance better, and it's just like that's like the thing with the memory tuning is like I am not like the timing adjustments I'm making, they're not there, like I'm not fixing stability with this. Okay? Like this memory kit with this CPU on this board would just run on the XMP profile. It would just be really slow. So the memory tuning isn't about like, oh, it's going to improve the stability. Like, yeah, that really isn't what this is about. It's about making it faster. So the main, basically, I'd say this is kind of inconclusive as to, like, how good the board is, because it's like, well, I know this is the best CPU I have. So it's just like, is it the board or is it the chip? I don't know. Right now, I kind of suspect that it's the CPU. So still need to do more testing on that. Anyway, hopefully you found this video, though also, I don't know how common it is to have CPUs with a memory controller this good. And I don't mean that, like, this chip is somehow amazing. It's just that, like, it's the best one I have. Right? So... And my luck with silicon, in my opinion, is terrible. Because, like, the only good chips I have are, like, second-hand CPUs that aren't relevant. So, yeah. Anyway, so hopefully you found this video somewhat interesting, if not particularly useful. And that's it. So thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a bunch of links in the description that you could check out, and that would be much appreciated. And yeah, that's it. So thanks for watching, and goodbye.